members, friends, veterans, VIPs, captains of the Indian plastics industry, and my colleagues. Let's start this event with the national anthem. I would request you all to please rise for the same.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मागे। गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Thank you. Bharat Mata ki. A warm welcome to everyone. I'm sure a lot of people are still in their way joining us in few minutes. We are here for a seminar on additive manufacturing, powerful toolkit for design to production, and driving value in product engineering and manufacturing through 3D printing, sponsored by HP and BOSCH. I'm Prasad Balan Iyer, the host for all of you today. Before we begin, we all have one great responsibility, and that is we all know the role plastic plays. Who better than all of us here? And we have our own member here, Mr. Rajesh Ghera, who had a beautiful suggestion that why don't we start this event with a small pledge? And I would read out the pledge, and I would want all of you to repeat with me. Yeah. So with the right hands extended. I pledge on this solemn platform to reduce, reuse, and recycle packaging, plastics, and all other materials. I will not litter, nor allow others to do so. It is our quest for cleanliness and to leave behind a far more greener earth for the next generation to live in. Thank you so much. So good evening once again. I take the privilege to commence the program and thank everyone present here for your time and support. I request Shri Rajat Mehta ji, Business Head, Personalization and 3D Printing, India, SPA, CSEA, HP. Shri Anil Kumar, HE, Technical Specialist, BOSCH, to take the dais. Shri Pankaj Shah, Immediate Past President of IPI. And Mr. Rajesh Doshi, Chairman, IPI Mumbai Chapter, to take the dais, please. Let me also remind everyone that we have a lucky draw. And all of you who have come in here, if you haven't registered outside and dropped your visiting cards, please do so. This will be towards the end of the program. Thank you, esteemed guests. I now request Shri I'm sorry. Yeah, I now request Shri Rajat Mehta, HP, to accept flower bouquet from Shri Rajesh Doshi ji, Chairman of IPI Mumbai Chapter. May I request Shri Anil Kumar HE from BOSCH to accept flower bouquet from Shri Pankaj Jha, Honorary Secretary, IPI Mumbai. Friends, this is a rare occasion for all of us to meet, greet, and enrich our knowledge network with our members from Pan India. We have tried to keep this opening session as short as possible so that our eminent speakers for today get maximum time to address our audience and share their presentations. Thank you all once again. I request Sri Pankaj Shah, Chairman, Governing Council IPI, to brief about the Indian Plastic Institute and its activities.
Hello. Good evening. The eminent speakers of the day, Shri Rajat Bhai and Anil, IPI members, my colleagues from the Governing Council, invited guests, ladies and gentlemen. Today, the technological advancement has become the prime importance and is considered to be the backbone for the success of the business. Additive manufacturing provides a powerful design toolkit and that allows for the creation of the complex geometries, intricate internal structures, and the customized parts, enabling designers to move from the concept of finished products with a greater freedom and the efficiency compared to traditional manufacturing methods, all while considering the specific capabilities of chosen additives manufacturing process. And to give the insight, today we have two eminent speakers from the HP and the BOSCH, Shri Rajat Bhai and Shri Anil Kumar. As a mandatory, we have to say a little bit about the IPI because it's a body which engage into the education for the and sharing knowledge for the members. And I would take this opportunity that whoever is not a member today can become a member of IPI. IPI, Indian Plastic Institute, a technical professional body, registered in 1985 under the Society Registration Act 1860 and subsequently under the Public Trust Act 1950. As a successor of Plastic and Rubber Institute, then PRI London, which was established in 1963, an overseas section of PRI London, now merged with the Institute of Materials. Friends, I'm happy to inform you that IPI activities are increasing every year, and we have started getting recognition from the plastic industry. During the last year, most of the IPI chapters have organized various programs which are useful to the plastic fraternity. One of our main objectives is to institute supervise and advance standard and methods of educating and training in the field of plastics. In furtherance of the object, our chapters at the different centers are conducting DIPI course, corporate learning program, and organizing various lectures, meetings, seminars, and the workshops. Today, IPI is a strong professional body of the industrialists, plastics technologies, academics, economics, students spread over almost 16 chapters across India, and we also have a 2 overseas association partnership with Sri Lanka and Nepal. We are engaged in educating the training manpower development, dissemination of the knowledge of the latest technological developments in the worldwide plastic industry. The contribution of IPI within the context of Indian plastic industry is unique. Organizing technical programs throughout the country, including conferences, seminars, lectures, workshops. In addition to its educational program, activities are no longer merger achievement. IPI play a vital and complementary role to universities and other educational institutes in drafting course circuli providing visiting faculty with facilities through its members and arranging the industrial training for the students. In keeping with the IPI is represented on the governing council of the Central Institute of Plastics Engineering and Technology, that is CPET. IPIs also represent the Bureau of Indus Standard, that is BIS, and for the promotion of the standardization and testing quality control procedure. IPI is spreading its wing globally and among global association and organization by the collaborating with Alan MacArthur Foundation, Ocean Recovery Alliance, and so many. Recently, we have just signed the MOU with the Denmark and the Germany for the sharing of the information on the latest technology. IPI has also partnered, with this, I would now request Rao to take further proceedings, and we shall await for the good seminar, awaiting on the 3D technical presentation by these two eminent speakers. And I'm quite sure when you leave this hall, you will be better in knowledge. Thank you.
Thank you so much. I request the dignitaries to take the seats in the front. I would also request Sri Rajesh Doshi ji to briefly introduce today's speaker, the first being Sri Rajat Mehta ji.
Thank you, Mr. Prasad Iyer. Good evening, friends. It's my privilege to introduce Mr. Rajat Mehta of HP. He is currently business head and personalization and 3D printing, India, SPAC, and ACA. Mr. Rajat has over 30 years of professional experience in the technology industry. He is visionary header and strategic advisor who spearheads digital leadership. He is currently managing the 3D printing business in ROA, region India, SPAC, and ACA, Southeast Asia, at HP. He also has extensive knowledge and experience in cloud, data center, GPU, computing, and edge devices. He has launched 6 multi-million-dollar technology business at HP India. Welcome, Mr. Rajat Mehta, sir.
Good evening, everyone. Am I audible? Last benches? There are chairs here. You can come in front if you want. Okay, before I start, a short introduction. I have been with HP for 24 years now. You don't find such pedigree these days. People change jobs in 3 years, 2 years, or maybe less. But I have been a happy HP employee for 24 years. This is the 6th or 7th business I'm launching for HP India. And it's my privilege to do the 3rd IPI seminar in this year. So we did it in Ahmedabad, then we did it in Baroda. We are now doing it in Mumbai. From Mumbai, we are moving to Bangalore. From Bangalore, we are coming back to Pune. Jai Hind! Jai Maharashtra! Jai Maharashtra! Shinde Saab will be very happy with me. Then we always break coconuts, right? Before starting something. So, and the coconut has to break. When we throw 3D printing part, it should not break. So I start with throwing a 3D printed part. The conventional thought process is that 3D printing is only for prototyping. Today we'll break that myth and we'll see how it can benefit you in various stages of manufacturing. while you're seeing the printer, the intention of this seminar is not to sell a printer. So we are not going to talk about the printer at all. I'm not going to tell about the price, when it is available, what is the delivery timeline, from where you can buy. Though that is not the intention. Intention is for you to understand the technology and see if we can fit somewhere in your manufacturing process. And if yes, then we have enough capacity in India, including Maharashtra, to help you produce parts. So you don't have to invest in the printer. We would love to sell, but not right now. You have to find right volume to invest in a printer later. Anybody from medical line here? Aarti? Okay, so I have some medical slides also. Sorry for, I and Aarti have this game that how many dentists are coming, and she said there's no dentist coming. I was looking at her. So we'll be primarily covering manufacturing, automotive, machinery and equipment, robotics and industrial, and drones. We'll do some bit of healthcare, and we'll do a little bit of material. This event is very, very special because in 30 years when I used to go and meet the industry leaders, one of the biggest problem I used to face is, hey Rajat, you are an IT guy. तुमको computer बनाना आता है, तुम्हें printer बनाना आता है. You are talking about manufacturing a vehicle. Why should we trust you? And it's a valid question. I don't know, my people don't know how to design a car or design an industrial robot. So we said, what can be done differently? And in September, we signed up a collaborative partnership with BOSCH that we will go together in the market and solve engineering problems together. So I'm very happy to have Anil here. Anil basically is my partner who designed this whole collaboration. The idea is that if you have an engineering problem, let me give you an example. You have to do, say, a casing for a medical equipment, and you don't know how to do it. You want to lightweight it, make it as light as possible. That project can be taken by HPA and Bosch and deliver the solution to you so that you completely get eliminated the tooling part of the job. You do everything on 3D printing. So this was signed. This is the first of its kind collaboration agreement in the industry. So I'm very happy that this is the first event where we are disclosing or we are sharing this with the IPI community. About HP, we are around, this is FY22, we are around $65 billion company, 58,000 employees, 250 channel partners. There are a couple of things which are interesting. We operate in 180 countries. We have 28,000 patents. Now, if you look at the entire 3D industry, we have invested around $1 billion in R&D for 3D printers. We launched the printer in 2016. We are the youngest, and our spend on R&D is highest. If you take 5 big companies or the top companies in 3D printing, they will not add up to $1 billion. That is the amount of R&D we have done. This is my favorite slide, and this is basically a myth which every 3D vendor comes in and says, ki aap printer le lo, you will get the moon. And we say that you will not get the moon because this is yet another one manufacturing process. Now, how many of you know 3D printing? Anybody who doesn't know? Okay, I assume that I don't know, so let me explain. So if you have an apple, okay, and I slice that apple horizontally and give you the slices, and I tell you that, can you assemble the apple back? So you'll take the lowest layer, on top of it, you put the next layer, next layer, next layer, and you'll build up the apple. Now I'll make it a little more difficult. If I say that within that apple, I want a TT ball or a table tennis ball. Now that's a challenging. For conventional manufacturing, you can't do that unless you cut it and join it later. Without joining is very difficult. So what happens is that you have 3 processes. You have formative manufacturing, subtractive manufacturing, and you have additive manufacturing. In subtractive manufacturing, it's your CNC milling machine, lathe, shaper. So you take a block of material and you start removing the material. Okay? So that's subtractive manufacturing. Then you have formative, which you are well known for, plastic industry, injection molding, sheet metal industry. You take a material and you form it to a shape. Either you will use a die or you will use a mold. So if you are doing a sheet metal, it will be punch and die. You will take a flat sheet, you will punch it, and it will be formed. So you have formative. What we are propagating right now is that along with that, you can have the third process, which is additive manufacturing. And there are huge benefits of having three processes. And I'll explain you why. These slides will take little more time, and then we'll run through. When you design on a conventional process, like if you're designing a 3D printer, injection molded part, what will be your constraint? That part has to come vertically out of the mold. When you're designing that mold, you will say, oh, I don't have a 5-axis machine, I only have a 3-axis machine. So my tool cannot go like this. So either I tilt the job for cutting, or I have to do with that limitation. So your designer come with that limitation, that I have to constrain myself to the machine I have. Okay, what happens in 3D printing is that the constraint goes off. You can design the part, a rectangle, a cube. Inside a cube, there could be a sphere. Inside a cube, you can have a cone inside. Can be printed without assembly. And I will show you a lot of parts. Now, can it be used everywhere? No. So the designer has to decide which process to use when. Now, the question will be, why do I need additive manufacturing? There are a couple of areas. One is that you don't require tooling for that. So when you're doing additive manufacturing, you remove the tooling cost. So if your volumes are, say, 20,000, 30,000, 40,000 parts a year, additive manufacturing has a lot of meaning, and it should be evaluated. You are seeing a lot of EV vehicles coming in. Lightweighting is a key. Again, 3D printing, you do lattice structure, and you can have light-weighted parts. Suppose I had amputated leg. In that case, a 3D printed socket becomes so much easier to wear. And we just launched with one of our partners, a company called Edivise, which will make sockets in 3D printing. These are some of the technologies which are available in 3D printing. And if you start calling the vendors, you will have every vendor coming in for 365 days trying to sell you a printer. Now, when you have such a commotion of technologies, you have to choose a technology. So when HP looked at entire technology spectrum, we said, we need something which is production ready. So we couldn't find any technology which was production ready, so we came up with our own technology. For polymer, we use, or plastic, we use multi-jet fusion. And for metal, we use binder jetting. And this is the reason why we use it. Most of the 3D printers, it's not visible, okay? Most of the 3D printers are in this domain. Prototyping, functional prototyping, testing of parts, and that's about it. What we are saying is that we want to go across the spectrum, which includes your prototyping, R&D, prototyping, then you have manufacturing aids, jigs, fixtures. Suppose you are doing a car body, which is a sheet metal, and it's a free-form sheet metal. It's very difficult to get that block right, where it will rest in the right orientation. I'm a car designer, so I speak in that language. But if you have a 3D printed part, which is in polymer, you can create that bracket very easily in 3D printing, attach it to metal bracket, and create the fixture very, very quickly. You can save almost like 75% of time if you do a combination of metal and polymer. Your checking gauges. When you are doing mass production, if you're a tier 1 supplier to any of the automotive companies, you have to do check-in, check-out, in the sense that will this pipe fit or this pipe will not fit. So you need a fixture for checking fixture. That is a great example for 3D printing. Now, some of you who are not a car designer might ask, why you have to check the pipe? If you have 1 degree variation in the front of the vehicle, by the time it reaches back, it will be at least 20 mm difference, and you have this cutout where the exhaust pipe comes out, it will not fit in there. So it's very critical that every component is checked in. If you want to do a CNC testing, it takes a lot of time. So you basically make a receiver gauge and see if it's fitting or not. Then comes a story where there's an end of life. Now, if Mahindra is launching a Thar, a new version of the Thar, the old version, you still have to supply spare parts. If you have to have all the tools stacked on the supply chain, you waste so much of money. If you can do 50% or 25% of the parts as 3D printing, you print on demand. One exaggerated example would be that if an aircraft is not working at Bombay airport. You don't have to wait for a Boeing to ship you a part. They can send a digital file securely, and you can print it on the nearest printer and put that part. This is a little exaggerated, but reality is coming there now. So our technology actually goes across this bell curve. Your designers or your engineers, when they look at three pieces, which is formative, subtractive, and additive, they should look at these areas. One is design freedom. The second one is, can I do lightweighting somewhere? And this is a big topic. We took an oath with the right hand stretched. This is a very, very important. Lightweighting becomes very, very important because it's ergonomic, it saves material, it saves the planet. Shorter lead time, increased flexibility, on-demand flexibility. How many of you are wearing 8-size shoe? Size 8. Most of the men have typically 7, 8, right? Your shoe and my shoe will be same if I bought from the same Bata store, right? But what if I tell you that everybody's feet contours are not same? So in Western countries now, there's a prominent thing called insoles. Now, we are testing at around 50 Bata stores right now, where you can put your foot on the scanner. It'll scan the profile of your foot, and will give you insole, which will make that 8-size shoes customized for your feet. The other example would be, because I see doctor in the front, or medical person in the front, will be on diabetes. A lot of people suffer from diabetes. And when it goes beyond a point, you have gangrene coming on the feet. So wherever there is a wound, you need to cushion that wound so that it doesn't hurt. So that, again, 3D printing is a great example where it can deliver. Customization and personalization is every vehicle or every part you produce on 3D printer can be customized. I was with one of the companies today in the morning called ArtNext. They're into packaging. And one of the things they were saying was traceability. So in 3D printing, we can have serial numbers on every part is unique. We can have labels created, which is very, very unique. And then you can consolidate the tool. What does consolidation mean? So if you have HVAC parts, the parts used for conducting airflow within a machine or an automobile, you can consolidate the part. Why you can consolidate? Because I don't have restriction of degrees of freedom. I can create a complex compound degree of freedom and do a 3D print. I'll give you 3 examples from my own supply chain just to make it very clear what we're talking about. Every plotter you buy has this block. The plotter is a large printer where you print drawings. This block was 355 grams. Typically, when we design the old school, people who have graduated in 90s, they take a factor of safety which is higher. And when you do a higher factor of safety, you end up with a part like this. CNC machine, 355 grams. What is the application of this part? It is a guiding block. So when this part, which goes to every HP plotter, came to our 3D printing group, they said there's no load bearing here. They did a CA analysis, and they created the first version on polymer from aluminum to polymer from 355 grams to 80 grams. Then said, that, can we reduce it further? So they hollowed it, or we call it lattice structure. So we hollowed it, and it went to 55 grams. And then we did something called generative design. For people who are new and, or who are business guys and not engineers, generative design simply understood as if you look at a tree, and if you want to predict how the branches are coming, there's no formula to that. No human can predict what God is using or what nature is using for the tree to come. Some of that algorithm has been put in the software, and you get structures like this, and this basically from 355 grams has reduced to 23 grams. And you can see the savings on top. Another classic example. A designer, this is basically slurry extraction tool in my laser drilling machine. So it basically extracts the slurry and put it in the bin. It was a MOQ of 13 parts, costing $450. If this part failed, it would take 3 to 5 days for the machine, and the entire line used to stop. This whole part was consolidated into one 3D printed part, which you see on there. From 575 grams to 52 grams, $450 to $18. Okay, so this is another part which we use on the supply chain. This is another example. This is basically an air duct, which goes in every printer we supply. This was the original one. And what you see is final one, which is generative design optimized. And you can see the saving. So whenever the engineer looks at the part, they should look at what can I do to save cost, to save time. Earliest time to market is money saved, money earned. Let's look at some examples. So in automotive, there are three great things which 3D printing can do. Gives you design freedom, gives cost reduction, and time to market. These are some of the examples. I don't know whether it's visible at the top, but these are all examples which are there on the field. So for example, this is a part from Continental. This is a part from BASF. You have a part from JLR. These are all production parts done on 3D, which means that for these parts, there was no tooling required. You straight away eliminated the need for tooling. You straight away 3D printed the parts. And we launched the printer in 2016 worldwide. From 2018 to 2024, we have one major brand or other adopting 3D for production. So it's not a fad or it's not something which we are throwing out of our head. This is happening actually. China is flourishing right now on 3D. We are hoping that India will catch up. And that's the reason we are partnered with IPI and BOSCH to make this technology popular with the industry. This is one example from Smith Vehicles Engineering. If you see this, the blown up bill of material, every part which you see here is 3D printed. And this is a commercial vehicle. This is a company called Osler. You would have seen How many of you have ventilated seats in the car? How many of you have cars with ventilated seats? 1, 2, 3. If a person like me sits on a ventilated seat, the air doesn't flow properly because my weight will compress the foam and the air will not flow. This is one great example where they have replaced the foam with a lattice structure TPU, which you can see here. There are two advantages of doing this. One is that the air can flow very easily. The second is in an unfortunate state where a driver has the accident, this absorbs shocks much better than a foam. And this is much more eco-friendly because this is 100% recyclable. And this is fire resistant, so the fire doesn't happen. This is another example. This is from JLR. Again, I don't want to keep tools static in my supply chain and wait for a dealer to say that, oh, I need a spare part, so then I put a tool back, print a part, and then the tool goes back and stays static. Instead, if I have a digital file, I can print the digital file on a printer. And this is example from JLR. This is another innovative one. Wax nozzle you use on the shop floor. If you need a different shape of the wax nozzle, you can do it in less than a day's time. You will have a wax nozzle which is curved like that. This is another example from Ford. This is an example for bridge tooling. Suppose you had a conventional injection molding tool, and that tool braked. What you will do, you will try to repair it, or you will send it to a vendor who supplied you the tool. What happens in that interim period? For that interim period, you can use 3D printing, and you can create the part and fit it in the automobile. As I said, customization and personalization. This is a great example. Mobile holder, cup holder. This is a small example. The second one would be a little exaggerated. You're gifting your girlfriend a car or a wife a car. You want the name to be put on the dashboard. You can do that with 3D printing. Every car could have a different personalization. It's very interesting. People who buy cell phones regularly, they end up spending, if you look at the cycle of cell phone as 3 years, the companies make more money giving you covers rather than on the cell phone itself. Especially if you are buying brands like Spigen and all, they make a lot of money. So customization and personalization, make a standard product your own product. It could be an insole for a shoe. It could be a dashboard customized to your friend or your family. It could be a cup holder. Everybody wants my car or my vehicle or my machine to be different than others. This is a wiring harness example. So either it's a carriage for wiring harness or is the end. So wiring harness is typically when you have connectors going from a battery to various components in the car, you use wiring harnesses. At the end, you will have a connector, which you can see here, and then there will be a guide. All these are great candidates for 3D printing. If you have very large parts, we can do large parts for functional prototype and prototype. We can do the bumper itself. This is another example which you should keep in mind is Zix fixture tooling within your shop floor. I'll give you a simple example. If you're manufacturing, say, 200 milliliter or 200 milliliter of Colgate tube, and then you have 500 milliliter. For holding, you require a different holding device. Typically, it is in metal. And it's very expensive. You have to stop the line, unscrew the metal fixture, and put in a new fixture. But if you have a 3D printed fixture, it could be snap fitted. And now we have ESD material, so it can be electrostatic discharge compliant. So that even in the electronic line, we can have fixtures which comply to the shop floor. And this is a classic example. This is what a compound angle is. You basically require a CMM machine, coordinate measuring machine, to measure the dimension of this pipe. But if you have a 3D printer, you can create a gauge where even a normal worker can basically put, if the part goes in, good, pass. If it doesn't go, fail. Simple innovations. And there's a huge amount of time saving. So if you go to Volkswagen, if you go to Tata Motors, any of these companies, and look at the time they spend in jigs and fixtures, and the amount of cost they spend is mind-boggling how much money can be saved. And we have Amuse 3D in Chennai, who is actually doing dedicated jigs and fixtures on the machine. Then you have personalization for key fobs. If you want the key to look a little different, you can have this. Then we look at the machine equipments. Here, the amount of money saving is much, much higher. This example is very critical. This is a can turner. If you buy a Coke can, typically the can are moving on the line horizontally, but for filling, they have to be turned vertically. For doing that, this is a mechanism which does that. If you have to do it on conventional manufacturing, you will do each of these pipes separately, then assemble it together. On 3D printing, it can be one go. Similarly, we talked about sustainability. Wherever you can save metal and put a recyclable plastic, is sustainability achieved. So we are working with many petroleum companies right now to convert metal to polymer. So from a stainless steel or a aluminum or any other metal, we are trying to convert to polypropylene. And this is live happening in most of the oil companies in India right now. These are a lot of examples from processing packaging machinery, agriculture, textile, woodworking, and other equipment. This, by the way, is L'Oreal mascara. So I was giving you a toothpaste example. This is a mascara holder. So when the mascara is getting filled on the line, these are basically the holding fixtures for that. And the beauty of this is that you can create a prototype where you can have the brush, the cap, and the base printed in one go without the need for any assembly. Robotics is another great area. You use servo motors in robots. So industrial robotics will use servo motors. If I put all the end of arm tool in metal, I need that power increase requirement for the servo motor. But if I can convert that end of arm tool to a polymer, I can make this robo consume less electricity. My servo motor voltage requirement goes down. So this is another example where 3D printing plays a big role. The other example would be that you're picking up something which is delicate. Having a plastic or a polymer end of arm tooling is much safer, that we can pick up the class very nicely and put it on the assembly line wherever it's required. And there are tons of examples. I'm not going technical at all today, but I'm just giving you some ideas. And I'll introduce my friends here who can print it for you, who can design it for you. So you don't have to buy a printer for that. These are some of the examples. Now, if you look at this one, I don't know whether it's visible at the back. This is all Madhumakhi ka chatta. Lattice structure is nothing but beehive. The inspiration in 3D printing comes from nature, whether it's generative design or whether it's hollowing structure or lattice structuring. Madhumakhi ka chatta, by the way, is the strongest structure. And now people are using that structure for spacecrafts, because it not only makes the weight lighter, but gives you much better strength. My favorite topic, drones. So which was the company which made headlines recently by going public on drones? Any idea? Any idea which is the Indian company who manufactures drone, which is now listed on stock exchange? Great answer. So Idea Forge started the work with us almost, Jana, it was 4 years? 4 years back, they started in a small room, and all the parts were done by Jana. Jana, can you stand up? Jana is general manager for Redington, who's our partner. It started with small experiments. Give me 5 parts, give me 10 parts, like that. Today, their entire drone is done on 3D printing. They're not only feeding Redington, which is Jana, but it's feeding 5 more service bureaus of ours. Imaginarium, which is in Bombay, which has got 4 machines, production machine. 2 machines are dedicated for Idea Forge. That is the advantage is that each of the drones can be customized. You can do lightweighting, so if your drone is lighter, it will fly longer. You can do drone as a service. So today you're using for agriculture, and tomorrow you use it for something else. You can repurpose the drone very, very quickly using 3D printing. One of the bad examples was throwing tear gas shells on farmer, but again, the drone was repurposed for throwing the tear gas shells. Wrong example, but that's the example. You can do the entire casing for drones, which you can see it here. You can do underwater drone parts, so which goes inside the water, so which means that the parts you are creating with engineering plastics are inert to water, gasoline, or any chemicals. This is a startup. VCross started from IIT Delhi. 2 young kids, 23 and 24 years old. They started this business as a part of startup incubation. Anybody has known VCross where they were recently? How many of you do Shark Tank? How many of you see Shark Tank? Most of you, right? The drone company which came in Shark Tank got 1 crore rupees from Aman was actually VCross. The entire drone is done on HP. This is a camera module for drones. So entire module which you see here is printed in one piece. So that's the beauty of 3D printing, that you have compound angles, you have complex angles, you can do it in one piece. You don't have to create assemblies of parts. This is another good example. It will not be visible from back, but these are aerofoils. So if you have a large drones, where was a large drone used recently? In Israel, to drop a bomb at a very well-known person's house. Okay, so in such kind of drones, you need aerofoil to make it lightweighted. And you can use 3D printing to lightweight the drones. Now that's again a bad example, but good example would be climatic surveillance, how the climate is changing. Or in Rajasthan and Punjab, you have tidde. You know what tidde is? The flying crickets. They spoil a lot of agriculture problems. They create a lot of problems. There, these surveillance drones can be a great asset. This is a beautiful example, which is of generative design. You could have structure like this. There's no way a conventional manufacturing process can make this part in one piece. And obviously not one piece, but they cannot make the part itself, because you will require maybe a 15-axis machine to machine this part. But this can be done in 10 hours of printing and 10 hours of cooling. And you can print probably 100 such in 10 hours' time. This is something which is very close to my heart. We use substandard sockets and so people who are unfortunately got amputated leg, We do manual making of sockets. It's very, very uncomfortable, unhygienic. You have people having rashes, so they will have bandages. And on bandages, they will try to insert the foot. Or somebody breaks a hand, and they will have plaster, which is after 1 month, you need something like a kneading needle. So you put it inside because it's so much itchy, because there's no air circulation. I have a customer in Delhi named Adroitech. They created people who have got 99% burn or 95% burn on one part of the body, and it's completely gone. When they're trying to do skin grafts, you need to keep that part or body exposed. They have created a 3D printed chamber with the air condition, so to keep the arm cool and inert to all the infections. So there are very innovative things you can do with 3D printing, especially on orthotic and prosthetics area. And this is what happens when you start using 3D printing. This is the insole. Somebody breaks a hand. Instead of having that itchy plaster, you could have just a 3D printed cast. And these are live examples which are available in India right now. A child with a cranial defect or a skull defect needs to protect the skull. When I was in 9th standard, I broke my skull. So that's why I'm a little erratic when I talk. But doctor told me for next 3 years, you should assume that you're wearing a helmet which is 10 mm thick, so that you should not bang your head anywhere. Otherwise, everything will collapse. But if you have a cranial helmet for kids as well as adults, this is a protection, and it's very, very lightweighted, because you can see all the holes here, which makes it lightweight and aerated. How many of you have heard of Jaipur foot? So we are recently talking to Jaipur foot and telling them that you can do better than plaster of Paris sockets. And this portion is 3D printed, assembled to a metal, and then you have a blade which is again 3D printed. So people can run even with amputated legs. So you'll have seen a lot of, they're called blade runners. The blade runners all were 3D printed. This is very common when you go to a good hospital which wants to make money, and you say that I have a spine pain. The straight answer is that go for a spinal surgery. When a person goes for a spinal surgery, you need a brace around to keep it straight till the time healing starts. And you can have 3D printed braces for that. The last one is a bionic arm. We have a company in Hyderabad. Again, Reddington did that work. It's called Maker's Hive. And they basically got inspired by Kalamji. And they made India's first cheap, low-cost bionic arm. And they're now supplying to all the citizens. The problem in India is that affordability is a big issue. So if you can make it cheaper, lighter, better, 3D printing is a way to go. This is the only slide I have on the technology. We are a powder-based technology, so we use powder. It could be polyamide powder, P11, PA12, glass beads. I don't want to get into those details. We'll put 80 microns of powder on the bed. We put 2 liquids on top of it, detailing agent and fusing agent. Fusing agent basically will make the material fuse when there is an infrared light. Detailing agent will stop it. So what you can do is you can get very sharp corners or very nice features when you do 3D printing. And because this is a technology developed by HP, by wearing the fusing and detailing agent, I can change the properties of the part. Like if most of the parts which you see are in gray color, but I can print a white part on the same machine by changing the agents. In future, I can have a transparency coming in of powder technology. People who are using 3D printing for now, we don't use any support structure. So you don't need to clean the supports. The part comes in, you do a bead blast, and you have the part ready. This is a portfolio of machines which we have. I'm not going into details, but these machines are ample available in India. All we want is basically next time when you are doing an industrial design and you have a problem, please call us and we will try to help you solve the problem. See if we can eliminate tooling for at least some of the material. We took an oath to make it sustainable. So if we don't do the tool, we are saving so much of metal. So in Bombay, we have Arpit has come? Arpit? Come in the front. Arpit is from Immaculate 3D, well experienced in 3D printing. He's based out of Bombay and now he's opened up an office in Bangalore. So you can contact him. Again, we don't want you to buy a printer, we want you to use the technology. So Arpit will help you. We have another player, which is Imaginarium. A lot of people of you know. There are many printers from our side. You can use Imaginarium. If you want somebody next door in Pune, we have Create 3D. And Arpit is expanding. So what you saw here, Arpit is actually manufacturing this for my partner Ediwise. So thank you, Arpit, for helping us. You want to say something? No, you can. Okay. So the idea is that you start using the technology. When you feel that volumes are right, we will come to your office and say that you are hitting a critical mass. It's a time for you to invest in the printer. You don't have to do a capital investment on the printer. We'll give you printer on lease. Okay? You can have various types of fit. Like your question would be that, while I can print in plastic, but I need an insert to screw the part. So you can have metal inserts in the and you have examples, Basha, right? Can you pass that part around? You can have snap fit. You can have ultrasonic welding. So you can weld the parts together, which are plastic. And you can do adhesive bonding also. So there are various ways of joining the parts. You can have various types of finish. For people from a medical fraternity, again, clear aligners is something which is becoming very popular in India. Started by Invisalign. Now Clove Dental is trying to get into that business. This is a great example. You can manufacture 1,000 molds, right, Jana? 1,000 molds for dental. Yeah. 1,000 molds you can do in one build. So in 10 hours, you can build 1,000 molds, and then you can do thermoforming and create clear aligners. So another great example. Thank you, Aarti, for not telling me that there is doctors, but I'm still reiterating that you could have 1,000 molds coming in from one build from the printer. Now what you see here is a normal painting. So if you buy a vehicle, what they use for other material, they will use the same process for painting the car. How many of you have XUV 700? The first 400 vehicles which came on the road had 3D printed parts, and Anand Mahindra actually asked the engineers to look at more possibilities of using 3D printed parts. It was done by a company called ITW, and again done by Reddington for ITW. All these materials we are talking are certified, so it's not that these are uncertified material, these are industry standard material with all the certification. And this is how a printing factory looks like. Very, very modern, very, very clean. And I'm a virus on LinkedIn, so anybody who wants to connect on LinkedIn can scan this QR code and connect. I've kept my talk very, very non-technical. Idea is that we don't want you to get lost in the technology. We are there to solve it. Give us the problem. If it's just a printing requirement, you could go to Arpit, and Arpit can print it for you. You can go to any of the service providers. But if it's an engineering problem, where you want to do lightweighting, you want to do complex parts, you want end-to-end tooling to be done, you contact me or Anil, and we will solve that problem and give you the complete solution as a turnkey. Okay? With that, I will finish my talk. I'll be here during the dinner time. Please feel free to interact. Yeah, sure. We do the question answer in the end or now?
We have a Q&A session. So once we are done with the second presentation, sure, we'll have a Q&A together. Yeah.
Anil?
Thank you so much for the excellent presentation. I was thinking what all could be made with 3D printing, but I think everything under the sun can be. I also had few questions, some of them were clarified by his presentation itself. So let's move on to the next presentation. I would now request Sri Jayesh Mehta to briefly introduce our speaker of the day, the next presentation, please.
Hello, good evening, namaskar, one and all. It's my privilege to introduce our second eminent speaker, Mr. Anil. Mr. Anil is looking after all 3D printing activities, start from creating awareness, consultations, design, simulations, and printing for APAC region, and focus to find potential applications in new product development. Indirect parts like fixtures, MRO, and low volume spare parts, and direct legacy parts. By education, Mr. Anil is MTech in tool engineering, and from 14 years of total experience, 7 years in BOSCH, and more than 12 years in 3D printing. So let's put hands together and welcome Mr. Anil.
Yes, very good evening, ladies and gentlemen. First of all, I'm really honored to be part of this event. Thank you very much, IPI team, for giving this great opportunity to showcase additive manufacturing capabilities in this forum. I'll be talking about today, my topic is driving values and bringing innovative solution in product engineering and manufacturing using different 3D printing technologies. Here is the agenda, what I planned for today's session. Let me start with key figures of our BOSCH group, and then competencies and services, what we could offer, and some of the use cases, what we have developed under indirect parts and A and B sample proto samples, and maybe I will end my session with Q&A. Quickly, I will go through what is that, the figures, for BOSCH group. We are into 4 different vertical segments: mobility solutions, industrial technology, consumer goods, energy, and building technology. So this is our main focus groups. So far, we have generated revenue of around 91.6 billion up to till 2023. And we have 430,000 associates across worldwide. And we have 468 subsidiaries and regional companies across 60 countries. So what is our competencies? What is that, BOSCH is focusing in additive manufacturing. So we are, just a minute. Yeah. We are COC for additive manufacturing. We take care of all additive manufacturing related activities, start from consultation, design, simulation, and then printing. So for APAC region. Since 3D printing is a niche area, we always, create awareness is mainly, vital, plays a vital role in creating awareness. For that, we do conduct a lot of trainings. We do conduct a lot of, seminars, webinars to create awareness on additive manufacturing. Once we do it, then we'll get into technical consultation. This is mainly to define the roadmap and also the strategic implementation in your areas. And next thing is DFAM, Design for Additive Manufacturing and Simulation. Most of the time, we take the conventional design and then use the same design for 3D printing. So then to get the maximum benefit, we have to do the redesign for additive manufacturing. That's what we do it. For that, currently, we have been using Creo, UG, and SolidWorks for design softwares. And for simulation, we are using Simuli and SimuFact. Since Rajat mentioned, there are so many technologies, more than 100 different technologies for both polymer and metal. So usually we gather information from customer, and then based on the customer needs, we will select the best technology, best process, best, the material, and then required post-processing operations. So this is what we have been doing it. And to provide turnkey solutions to all the customers, We have strategic partnership like OEM with HP, universities for R&D topic, and we have 12 vendors, different vendors for printing of both metal and polymers. So this is all our competencies. So this complete ecosystem is established to give end-to-end solution. You give us the problem statement, we will approach you back with either topologically optimized or part consolidated 3D printed part. What is that service offerings we usually start? Consultation. I told you, right, we gather information. We gather information in two parameters. One is economic and technical parameters. If it says, yes, these parts are 3D printable, then we will get into DFAM, design for additive manufacturing, where we implement topology optimization and part consolidation. And since we are going to change the design, this design has to be verified. For that, we do the simulation process. And the final thing is printing. Printing, we have in-house polymer printers, and if it is not possible to fulfill the requirement of the customer, then we'll get it done from our vendors. So this is all about our competencies and service offerings. What are all the matured areas in 3D printing? In Bosch, we believe that 3D printing is a game-changing technology, especially in the manufacturing scenario. One of the area is indirect parts. Indirect parts used to manufacture our direct parts, mainly in the assembly lines, like fixtures, grippers, gauges, part handling systems. So these are all the indirect parts. One of the classical example is, so when we got the project, so usually we go to customer place, the first general question is, what is your pain point? Then they said, this is a black color wear pad. This is, the problem because it wears every 2 to 3 weeks of time, and it is imported. And this cost around 600 rupees for one part. And then we started looking at this, localizing this. Then we came to know this wear pad is wearing because of weight of the WPC. This is called workpiece carrier. So this is used to manufacture our glow plug component in one of our plants. So this is kept on the conveyor, moving conveyor. It moves from one station to another station. Then we asked, instead of owning the part level, can you own the complete assembly level? Then they agreed. So when first when we started, we did not have CAD data, because for 3D printing, 3D CAD data is must. Even though we have manufacturing drawing, we have to get into reverse engineering, generate 3D CAD file, and then do it. First, we started with plastic component. When we got the plastic component, when we met customer, they said, you go ahead and do it for one sample. Then we consolidated all the requirements, problem statement. Then we had come up with something like this. So this is the 3D printed topologically optimized part consolidated part. If you look at this part, this is a classical design for conventional part. If I use the same design to get the maximum benefits, we don't get it. So we have to reduce the weight of this part. So this weight was almost 1.1 kg. Now this weight is 0.58 kg. So now with this, even though they wanted to run with 85, 95 numbers fixtures in the line, but they're running with only 50 to 60. Because of this weight reduction, now they're running with more than 85 numbers. So these kind of value addition we have been giving it. If you look at the weight, and this is a video I would like to show. This is our glow plug is our direct component, and the fixture is our indirect component. So this is how it moves from one station to another station. Now they are running with more than 85 numbers. Now the cycle time has been reduced. They are getting a lot of benefits. When we hand over the first iteration, they have identified, means they gave one more problem statement, because if you look at this wear pad fixed to this base plate using 2 screws. They said, can you avoid the metal screw? Because if they don't monitor the wear on the wear pad, the screw was damaged in the conveyor belt. Then we have introduced the snap fit mechanism. So now it's been more than 2.5 years, they have not changed the wear pad. Earlier it was 2 to 3 weeks of time because of the weight. So these are all the use cases what we have done. Now workpiece carrier has become low-hanging fruit for 3D printing. Wherever we go to Bosch plants, we usually find, because our products are almost similar, we can find and then usually implement this. So now another workpiece, but it is a plastic component. But here, they did not have any kind of weight issue, but since it was imported component, the issue was larger lead time and cost. First, what we have done is, since it is a supplier or OEM part, there are no manufacturing drawing, they had only the physical sample. So we took the physical sample, we have reverse engineered, we have generated the CAD data. Now we have implemented almost 100 numbers in the line. For the first year, it is almost, it will be 12,000 per part, even though they need around 100 numbers. But the next year, it will be, approximately 2,000 to 3,000 per part. The first year, because we took a lot of, energy or efforts to convert into, to generate CAD data and for reverse engineering activity. So this is another example, coolant nozzle for one of the grinding applications. If you look at the existing coolant nozzle, so the coolant was, the flow was turbulent, and it was not falling onto the product and also onto the grinding tool. Because of that, they are having NTZ and NHZ issue. So this is the problem we got it. Can you help us on this? And it was designed for metal part. Now what we have done is, we have initially started with used our in-house FDM printers. We made a first version of design. We were able to address the NTZ and NHZ issue, but still FDM parts are leakage. It is leakage will happen. So now ultimately we have to go with MJF process with the GB material. We were able to reduce the rejection rate, quality defect rate to less than 1%, and earlier it was 10%. Every day they use the rejection rate is almost 3,000 components. That means they manufacture 3,000, 300 components used to reject because of NHZ and NNTZ. So now because of the laminar flow, the rejection rate is 1%, and the cycle time, the machining cycle time got reduced to 49 from 72 seconds. Here, as I said, workpiece carrier become the sweet spot, right? We have now done almost more than 12 different varieties of workpiece carrier. You can look at the lambda sensor, PSR for ABS, injector. The injector one, actually, we usually convert from metal to plastic, but here we have to convert into plastic to metal because plastic life was very less. That's the reason we had to go with the topologically optimized part. We have chosen aluminum material. We introduced topology optimization to balance the weight of the part, and then we have delivered. If you see all the cases, we have reduced the lead time, we have reduced the manufacturing time. And these are all actually different coolant nozzles for different grinding applications. Coming to second area, that is A and B proto samples. 3D printing is really proving to have a vital and permanent role in product development. In accelerating, improvising, and bringing a lot of customization. How 3D printing is enabling in new product development area. So this is one of our healthcare components. 5 years back, Bosch is very new to healthcare, especially this kind of product. They want to have the design, means fine-tune the design, also to finalize the material manufacturing process. So for that, what we have done is we have used multi-jet fusion technology, MJF, PA12 material. When we have the component in our hand, we were able to fine-tune the design. We were able to finalize the material because we anticipated in one of the products, we anticipated shrinkage and warpage. Because of 3D printed part, we were able to change the material to plastic to metal. So this is how we have been using it, and so that our development cycle will be faster. There is a famous saying in 3D printing, if a picture is worth of 1,000 words, same in context, a 3D printed prototype is worth of 1,000 meetings. So this is a classical example. The same way in power tools, in one of the drilling machines, when we produced initial samples, one of the child parts was interfering with the housing. To rectify that assembly, what we started is we started with liquid-based technology, the transparent material. We came to know which child part is damaging the housing. But to run it for 300 hours, we want to have an engineering grade strong material. There we have used MJF process, PA12, and then we have tested for almost more than 300 hours. So this is how we have been using at our facility. 3D printing is enabling so that we can reduce our time, development time and cost. We did it for drilling machines. Now we took the same confidence level and then we did it for blower and also the vacuum cleaner. So and marble cutter as well. So but for marble cutter and the blower we had to go with PA12GB material. Electrification topic, yes, 1 or 2 samples, very complex component. They want to do the PCB potting. And this is almost 300 mm in length. It is very difficult to do it in conventional process. We had to go with 3D printing, and this is one of the universal charger for electrification. And see the geometry of this coolant to baffle this one. So it is very difficult to do it in conventional process. The overall intention was met using this 3D printing because it is in the initial stage. It is a B sample stage, faster development. And these are all some of the other projects what we have done where overall development time and the cost has been reduced and also the lead time. So finally, the facts and figures. So far we have printed around 2,000 components. Out of that, 40% belongs to metal, and 500 parts are re-engineered, means we did the DFAM. We have to do the DFAM to get the maximum benefits. Otherwise, 1:1, since it is a 3D printing, material cost is very expensive compared to conventional, we had to go with the DFAM. So that we had done 500 parts engineered, and we have saved $0.25 million USD for all the BOSCH plants. We have been supporting to 8 BOSCH plants in India, and our team size is 5. We are working for design and simulation. So in average, we have reduced around 40% of the lead time, and cost reduction is 25% in all the projects. And 3D printing, you cannot sell the topic or you cannot give the innovative solution only by keeping 3D printing. You should have the conventional knowledge. That's the reason I mentioned hybrid. Since we do a lot of optimization, part consolidation, a lot of material will be saved. So that's the reason I brought under reduction in carbon footprint. With this, I'm open for question and answers. Thank you so much.
Thank you so much. Thank you so much. Can we get 2 chairs, please? We'll open the forum for questions. We can take about 10 minutes of Q&A. I am sure a lot of people have questions. I'll invite Mr. Rajat Ji also on the stage and Mr. Anil Kumar. Yeah, please do.
There are some of the friends who are there for your friends from now today. So can I have Team Wintech coming on the front? Team Wintech. Mr. Jana. Arpit from Immaculate 3D or Quick Parts. Mr. Basha.
Hello.
So these are your champions, not only for during dinner time to ask more questions, but if you have an engineering Anil, sorry, I forgot Anil, he's here. What is significant here of Bosch and HP coming together is that together with our knowledge base, we'll be able to solve most of your critical problems which you want to get addressed through 3D printing. And without owning a 3D printing, without knowing a 3D printing technology, we are there to serve you. So these are your friends. During dinner time, please interact with them, exchange the business card, and whenever you have a problem, please let us know and we'll be more than happy to solve the problem. Thank you so much.
Yeah. Hello. Rajat ji, can I ask the question, please?
Yeah, it's okay.
chair ला रहा है. Hello. अरे यार, time pass. Good evening, sir. This is Pranav Mistry here. Here. यहाँ पे साहब. Yeah, I can understand. This is Pranav Mistry again. First of all, excellent presentation, sir. Excellent. I am really so enlightened. As I told you, I met Mr. Rao and he did in Adonics through Dassault Systems a similar presentation. But yours was the best till date in 3D printing, I can tell you. Really good. Yeah, please. No. So small questions, 3 of them. What is the highest level of temperature material you can print latest, because I'm not aware of the latest technologies. What is the material temperature grade you can maximum give? Inconel, moly or any powder which is similar to that, can you give? What temperature?
Regarding metal?
Any material up to what highest temperature you can 3D print? Material can be any.
It is a tool steel called maraging steel that can be, melted till 1250 degree.
1250
degree.
is possible?
Yes.
Okay, we'll keep it later because I'm keeping short. Yes. Can the 3D printed parts be reused? Because you're infusing with separate some other methods. There are several methods I know. But can these parts, after usage of some damage, can be reused?
In plastic, no, it cannot be done. But there are some technologies in 3D printing available, especially for metal. But again, it is depending on the base material and the design, the wear and tear, how it has happened. So it is, overall, we need to take, the overall considerations and then take a call.
Yeah, but most of them are not usable, what I presume.
So if you are talking about recyclability, you may not use that in 3D printing, but you can melt it and you can use it for some other purpose. We are working with a company, global leader called Akima, where they can use the unused powder and the material, grind it and make new products out of that.
Okay.
So that's possible.
Yeah. And what is the maximum level of surface finish RMS value you can get as on today? Because earlier figures were there with me. What is the latest surface finish RMS value can you get in 3D printing?
Professor Jana?
So the normal material which is available mostly with all the service bureaus are PA12, that is polyamide 12. The RI value will be around 5 to 8. That is the output we normally get around
microns.
This thing. That is and if we have launched a new material called PA12L Smooth, where we are able to bring it down to almost 3 micron, 3 RI value of 3 microns.
RI value, that's
fantastic.
And then if I do a surface finish operation after that, I could have a class A surface coming out of a polymer printer.
Yeah, okay. 3 micron is quite
so
quite
we can
smooth.
do vapor polishing, for example, to give you the finish which is required for exterior of a car.
Yeah, absolutely. That was perfect. And any plan of HP entering into civil construction printing? Because these are, of course, small machines. But I am hearing that a lot of demand is there for civil construction printing, which IIT Madras and Elon Musk and some other American companies are already doing. So I would request that would be a good.
By nature, we are greedy. So the manufacturing is $12 trillion market. And if I take 1% of that 12 trillion, I can support another HP organization. So till the time construction industry becomes mainstream, it will be a R&D project which we keep doing at the lab, but you will not have commercial printer coming out from HP's table till the time we feel that the industry is matured to use 3D printing. Right now what you're seeing is one-off. Bangalore post office was done by 3D printing. Somebody will go inaugurate and create a big news. But for mass, it's not happening right now. But the moment we feel that the technology is ripe, and one thing we have to always keep in mind, what is the economic benefit from a conventional versus new methods of working?
That is.
So if it makes meaning, yes, we will do that.
Thank you for your excellent answers. Thank you, sir.
Yeah, Rajat, can I ask the question?
My name is Vasant Uchil. I'm from the thermoset industry. Thermoset, not thermoplastic. has a 3D printing machine used for making any component using epoxy resin or polyesters or
Not on my
phenolic?
technology, but other technologies are available.
No, there are some new applications from Indian Army who are asking for drones which has to withstand high temperature and which can be done only by thermoset resin system.
That can be achieved. And I will request Jana to connect during the dinner time and answer that question. We'll answer that all the questions.
Thanks.
Rajat bhai, I'm Pankaj Shah. Yeah. I'm the past chairman. I have a question. What is the maximum number of 3D printed components can be done in a day compared to the molded components? Because as you presented some of the slides where injection molding can be challenged.
No, we don't challenge injection
In
molding.
the sense that what is the maximum?
So I'll put it in terms of quantity.
And
If you are
what
doing
is the cost advantage?
anything
compared to-
under 50,000 parts
Yeah.
requirement, 3D printing is great. Especially our technology is great. In terms of the speed, 43 to 44 liters of printing happens in 8 to 10 hours and 8 hours of cooling. So in 16 hours, you can have that kind of volume parts coming out. Now, there is also, I don't want to go into detail, cost economics is a factor of packing density, how nicely you can pack that 43 liters. So the cost per part goes down if you pack it properly. So which means that if you have bigger parts and smaller part clubbed together, you get much more cost per part out of that. But anything which is 50,000 and below is a great candidate on this technology right now.
So in compared to the molding, the cost will be lesser?
You straight away eliminate the tooling, right?
No, that's okay.
You eliminate
But
the tooling.
then the restrictions comes that you can only use the PA12?
No, we have, as I said, I did not go into details, but we have PA12.
No, which are the materials can be used?
So
it's a
PA12
benefit for the all over here.
PA12, which is polyamide 12, polyamide 11, polyamide 12 glass filled. Then we will have polypropylene, TPU, TPA.
Okay.
Then we are launching in Formnext in November fire retardant material. We are launching ESD material, which will be electrostatic discharge compliant. So anything which is into electronic industry, where you have current passing through circuit boards, you need a ESD fixture. And that can be done straight out of the 3D printer.
Any material, engineering material like polycarbonate, can you handle?
Polycarbonate.
Yes.
At present, no.
Okay.
But what we do is, that's where DFM comes up into picture. If you don't have that material which is required, we look at the closest material and see what benefit analysis we can do with that material.
Thank you.
Mr. Rajat, as he said, excellent presentation by both of you. Congrats. Just to add on to what he said, PC, you have this PETG, which is almost equivalent material, which is really used for 3D printing. Just my question is, you said in sustainability, you suggest use of biodegradable materials in one of your slides. So has it been tried out? Because we did some trials with PLA and other materials. Plain molding is fine, but anything intricate, it is very difficult to do those injection molding.
Sustainability has two dimensions. So the way we achieve sustainability is, whenever I'm doing a build, 80 to 85% of the powder is from the previous build. And only 15% powder is new. So that is one area. Second, for example, PA11 is made from castor bean, the castor oil, castor beans. It's grown in Rajasthan from that PA11. So it's completely sustainable and it's got a 100% ratio. So you can recycle 100%. So this printing, because you are doing layer by layer and you are not cutting the material, it's extremely sustainable. Plus, we are using sustainable sources to manufacture the base powder for that. And that's the reason why you saw sustainability mentioned very prominently.
Thank you.
Yeah.
So again, Rajan bhai, very great presentation, and I think no one moved, everybody was sitting there. Myself is Bhavesh Gandhi, and we actually manufacture CCTV cameras now. Earlier we used to manufacture the plastic part of CCTV cameras. Now we are manufacturing the whole CCTV camera. Now the thing is, you said that you are coming up with the transparent part of things. I think it is in process?
It's a future, but there are printers which can do, see again, for doing transparent part, the cost economics right now is not right.
Okay.
It becomes very expensive.
Okay, okay.
So you are conventional methods of doing transparent part, which is cheaper.
Okay.
What we can do in CCTV is the entire casing can be done in one part. You don't have to need an assembly, and the camera module can go inside. And all the drone manufacturers today are doing the camera modules on 3D printing now.
Oh, great. So I think I'll have to meet, who's the person who does this? You said? Arpit, yeah. Yeah, Arpit, we'll meet, yeah, thanks. Thank you very much.
Yeah, please.
So from someone who's from an injection mold manufacturing background, I've been hearing a lot of technological developments which are related to 3D printing as far as injection mold core and cavity inserts are concerned. But I mean, I could feel that your current presentation was focused more on the individual parts rather than parts of an injection mold. So could you enlighten us something about that side of the technology development?
All your extraction tool, when you're extracting the parts from the injection mold, those automation can have 3D printed parts.
Okay, no, I was talking about the actual core and the cavity parts,
Yeah, so
which are like conformal cooling is also one of the advantages.
In inline cooling, channels can be done on 3D printing, which cannot be done on the conventional.
Okay.
Those channels can be very easily done at 3D printing. If you are doing metal, Endomem in Bangalore has just put in 2 printers running 24/7, and they will be able to design the cores and cavities with inline cooling. If you have a problem, you can come to us, and we can solve the problem for you.
Thank you. Thank you.
I have a diversity problem here. All the boys are asking the question, no girls are asking the question. Yeah.
Hi,
Hi.
I'm Shimul.
Hi.
So, just a very basic question, no technical questions. How do you envision additive manufacturing to scale in a cost competitive or cost effective manner? How do we go beyond 50,000?
This is a very, very prominent question, and this is a very, very good question, because when we launched the printer in 2016. The first printer was launched 30 years back. I sold my first printer in 1985, and most of you were not born. At least some of you were not born. Now, what we have done is we have worked with the plastic manufacturers or metal manufacturers and made them the source for the material. So that has given us this economy of scale to bring down the cost. As the material cost is going down, it will start becoming more and more mainstream manufacturing process. In certain cases where you have complex angles, where you are combining assemblies, it's straight away taking the mainstream. Right in India, in Bangalore, ISRO, there are so many parts done by Wipro 3D, which goes in the space, and the only way you can manufacture those parts is 3D. I gave you an example of a socket. So I can have a TPU lining to make the socket comfortable, and I can have assembly in one socket, which can basically increase or decrease the pressure on the amputated leg. And that's only possible on 3D. As I said, you have to look at all the 3 processes, subtractive, formative, and additive, and decide which is the best optimum combination. And Anil highlighted hybrid manufacturing. So we are not saying that 3D is going to replace any of the conventional, nor conventional is going to kill 3D. It's basically coexistence. So if you are into Industry 5.0, Industry 4.0 was a big flop, because they said technology can do everything. Then they realized, no, technology cannot do anything. Now we need cobots. So along with the robos, we need humans. So it became cobots. So Industry 5.0 is basically inspired from an Indian marriage, that you might have differences, but if you can collaborate together, the house will run properly. So that's Industry 5.0 in my language.
Okay, thank you.
Good evening. Thank you. It was a lovely presentation. I'm from the raw material side. My question is, like conventionally for all the plastic processing, raw materials are manufactured considering the processes. Now, for this 3D printing, what exactly, is there any development or anything specific required? See, we were talking about PA, but there are so many other plastic raw materials. what is it that you have for raw material manufacturers?
So every technology requires different parameters. So if you're using a filament in case of FDM, that filament has to melt at one temperature, fuse at one temperature, so that becomes a critical parameter. Because we are a powder-based technology, the flowability of the powder is a critical factor. So what we do to material manufacturers is basically give that specification of what powder we require, what flowability is required, and basis that they will develop the powder. Now the flip side of that is that if I go to a company like Reliance and say that you manufacture 3D printing powder, they will ask me question how many thousand trucks you require in a day. But that volume is not there today for 3D printing. So we are choosing partners who make meaning for them and for us, like BASF, Lubrizol, Akima. These are some of these partners of BASF who are basically manufacturing powders for us. The idea is to bring down the cost of the powder, which means that cost per part very soon will actually match or let be little slightly above injection molding, giving you same properties, but giving you much more design freedom.
But you know what you were saying is the cost, bringing down the cost on based of volume is what you have been, anticipating, like, right?
That is one. Second is creating properties.
Okay, properties.
Like on the same machine where I'm doing a PA12 normal, on the same machine I can do ESD material printing.
Okay.
On the same machine where I'm doing a gray part, I can print a white part. So that is all changing the properties of the material or the base material. So those are material innovation, and we have a scientific group inside our company which works with a material manufacturer to get that things happen.
Wonderful. Would you suggest, we take up with our company, because I'm from Supreme Petrochem, some kind of developing specific grades? So if you can let us know.
I am a hardcore sales guy.
No, you said you have a scientific
I am a
team.
hardcore sales guy, so for everything I say yes, but the answer is no, because we have to have multiple discussion with the R&D folks to see the feasibility, whether it makes economic meaning for you. If it makes economic meaning for us, the collaboration is possible.
Sure, maybe later we can talk on that. Thank you so much.
Hello, myself Parag. I am basically into manufacturing of machines and molds, injection molding and blow molding. My question is that, say if I have something within 50,000 pieces and I don't want to make a mold and I want the things to be done in a faster pace, what would be the extent of aesthetic of my product? Can it be reproduced as it is, or are there any limitations? And secondly, what is the biggest size that we can go? See, if I want to print a AC cover or maybe a part for something in household appliances. So is that possible, or we have to have some compromise on aesthetic and other parts?
Okay, so that's a good question. So as I mentioned that there are joining techniques, but that joining techniques may not work when you are supplying a part outside. So basically then Anil comes into picture as BOSCH, and we look at your assembly, see what is the requirement. We might require multiple processes, so we decide this portion will be done on HP, this process might be done on some other machine. This is the metal part which needs to go on a binder jetting, and that's where you decide. It's like conventional design, right? I have a 5-axis machine, and I have a, say, a lathe machine. What part goes into 5-axis machine? What part goes into lathe machine? Similarly, what goes into MJF printer, HP printer? What goes into, say, a US printer? Depending on that, we can do parts.
But say if I want to make a simple sharpener for children's, I don't want to make a mold. Can it be replicated as it is?
Absolutely.
in PP?
So you could make the plastic component in the printer. The blade component can be a conventional because it's cheaper to buy a open blade and screw it together.
But aesthetic would be the same?
Yes.
Or do I have to compromise on that?
We can do it better.
That's great. Thank you.
I am hungry. Anybody else is hungry?
So I have this is just a question which just came up. So you were talking about, Mr. Anil was talking about design for additive manufacturing. I think possibly one of the areas is if there is a fused deposition mold, FDM, and you have an MJF. Yeah, is there a difference in the design for additive manufacturing in these two technologies? Should the designer of a company be aware of it?
Yes, FDM parts are anisotropic in nature, because in X and Y direction we get 100% the strength, but in Z direction it will be weaker. Yes. But if you take MJF, it will be isotropic in nature. So this is a designer should know. In FDM, you should always think about the orientation.
Right.
But here it should not be because of isotropic in nature.
Okay.
So these are the main difference under DFAM.
Right, right, okay. Okay, great, excellent answers and explanation. I would now request Pankaj ji to hand over a token of appreciation to Mr. Rajat Mehta ji.
You know, this is the best part of IPI events. Every time I go for an IPI event, I get a gift.
Rajesh ji, if you can. Would also give a token of appreciation to Mr. Anil Mehta. There is, just to add, there is also a special token of appreciation that is provided by Dehraj Foundation. I would also request Rajesh Doshi ji to hand over those token of appreciations also. Thank you so much. So as part of the plastic awareness campaign and under the corporate social responsibility, IPI and Millicron have joined hands together for this activity. Can we have the video, please? Just a gentle reminder to all the guests and members who probably joined us late. We have a lucky draw, so I would request the lucky draw box to come in forward. If anyone who has not dropped their card or forgotten to drop their card, please do drop in. We don't want paper chits with names written. We actually want your visiting cards in the box. Can we have the box, please? In the front. If there is anyone who wants to add the business card, otherwise we will go in for the lucky draw. No committee members, please. May I request Shri Chetan Shahji to conduct the lucky draw for us?
Good evening. I'm not going to take much of your time. Are we ready with the cards, please? Just to inform you all, if any managing committee member's name is picked up, gracefully and politely decline so that the others get the chance. This is our normal IPI norm that we committee members don't do it. Right? Can I ask Rajat to pick up one of the cards from there? I'm sorry I'm making you walk and you're hungry. I can't see. Oh God, you are the one. Supreme, Mr. Narayan. Gift. Rajat, I would request you to please hand over the gift to him. So now you can, you can accumulate it. Come. Congratulations. Anil, can you please come and pull up one more card? Not one more, pull up a card. Jai Shethe. Only the persons in the hall will get it, or we go further for the next card. Sorry, it's not a. Ah, yeah, here you are. Sorry, I didn't see you. So there is one more. Prajavati, can I request you to please pick up the box and go to the lady who asked the question, let her pick up one. Yeah, I know. Now, who's going to give this? Rajesh, can you give it to Nirav Seth? Thank you very much. I'm not going to take much of your time. I know a lot of people are thirsty rather than hungry, so I'll leave the stage.
Thank you, Chetan Bhai. We have a special announcement by Mr. Rajesh Doshi.
Thank you, friends. Thank you very much for being present here in the program and grace the seminar, our seminar event. There is one special announcement. We are very much glad to announce that there will be a one-day conference in the month of December. The topic is sustainable polymer additives, developments and applications in recycling. So again, it is a sustainability which is the need of the hour. It will be conducted on 13 December at the Hotel Orchid. The details will be sent very shortly to all the members. So kindly block your dates in the calendar, 13 December. We are also planning one more seminar in the month of January that will be on the injection molding, new technologies and some innovations for power saving and other technology. So be prepared to attend that in January. We'll be announcing the dates very shortly, and that will be also given to. Yeah. Thank you very much. I may now call Mr. Iyer.
Thank you so much. I would now request Mr. Parag Dave to propose the vote of thanks.
Hello, everyone. Thank you for this opportunity. Basically, I am secretary for Mumbai chapter, and I am really overwhelmed to welcome you for this enlightening session, and I hope you all must have enjoyed it very well. I would really thank on behalf of our IPI Governing Council, also Mumbai chapter, to the HP and BOSCH Global Software Technologies for presenting such an excellent information to all of us, and I'm sure everybody would have added to their information because 3D is very much talked about, but not most of the people in the industry know it to the core. Also, I would like to thank our IPI Governing Council, Mumbai Chapter Committee, and other office bearers for their guidance and support in organizing this lecture, and would also acknowledge Mr. Rajesh Doshi, our chairman, and Mr. Sandeep Sindhe, our back office secretary general with his staff, who has been working hard to get this thing done, which is in front of you all today. And I would again thank Mr. Rajat and Mr. Anil for their efforts, and it was really one of the best presentations I have seen on this topic. So thank you very much for bringing this information to all of us, and we will look forward to get other information to time. And last, I would thank all the attendees who have taken their time out and being here for us to attend this and make this program successful. And we, on behalf of IPI at whole, promise you that we would be definitely bringing you more informative lectures of similar kind, and we all will be getting together from time to time again. And last and not the least, I would also thank Courtyard, Marriott and their staff for giving all their cooperation for making this successful. And now, not taking much of a time, I will invite you all for networking, dinner and cocktails. So enjoy your time, and I wish you all the best. Thank you.
Thank you so much. I'm not standing between you and the cocktails and dinners. A small announcement for those guests who are not members of IPI. The events that are happening in December and January are member events. We would request all of you to become members of the IPI. Could be life members, could be annual membership. Please go to our counter outside and we'll be happy to engage with you. Thank you so much and good night.